Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Web Application Firewall, the system that protects web applications from SQL injection, cross-site scripting, bad bots, credential stuffing, and DDoS attacks. We'll cover how WAFs inspect HTTP traffic, enforce OWASP rules, detect bots, apply rate limits, and log everything for security teams. Whether you're preparing for a senior engineering interview or building application security at scale, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Web Application Firewall, the system that sits between the internet and your web application and decides, in real time, which requests are allowed and which ones should be blocked. If you have ever wondered how companies stop SQL injection, cross-site scripting, credential stuffing, bad bots, and distributed denial of service attacks without breaking legitimate user traffic, this video is for you. We'll walk through the functional requirements, non-functional requirements, high-level system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FANG interview or building application security infrastructure, let's get into it. Here is the core problem. A modern web application serves millions of requests per day from users, partners, APIs, and mobile clients. But not every request is friendly. Attackers probe endpoints for SQL injection, inject malicious scripts in form fields, flood login pages with stolen credentials, scrape pricing data, or launch Layer 7 DDoS attacks that exhaust the application. A traditional network firewall only understands IP addresses and ports, so it cannot inspect HTTP payloads, user behavior, or application-level anomalies. The application team needs a web application firewall that understands HTTP, TLS, cookies, headers, and bodies, enforces security rules, detects bots, applies rate limits, and gives security engineers clear observability into what is being blocked and why. Let's walk through the functional requirements. First, the WAF must inspect HTTP and HTTPS traffic, including headers, query parameters, cookies, body content, and file uploads, so it can see what the application sees. Second, it must enforce a rule engine that supports signature-based detection for OWASP top 10 threats like injection, cross-site scripting, broken access control, and security misconfiguration. Third, it must detect and classify bots, distinguishing between good bots like search engine crawlers, monitoring agents, and legitimate APIs versus malicious bots doing credential stuffing, scraping, or account takeover. Fourth, it must apply rate limiting and throttling per IP, per user, per session, per API key, or per path to stop abuse and protect backend capacity. Fifth, it must log every request and every blocked event with enough detail for forensics, compliance, and tuning, and expose a management console for configuring rules, viewing alerts, and updating policies. These 5 capabilities are the core of a production-grade WAF. Now the non-functional requirements. The WAF must add minimal latency, because every request goes through it. Security that slows the application too much will be bypassed or disabled. It must handle massive throughput, often hundreds of thousands or millions of requests per second, with horizontal scale-out. It must be highly accurate, meaning it blocks real attacks while minimizing false positives that break legitimate traffic, which is one of the hardest trade-offs in WAF design. It must be highly available, since if the WAF fails, either the application is exposed or the application goes offline. The system must be observable, with real-time dashboards, logs, and metrics for security teams. It must support fast rule updates, because new vulnerabilities and attack patterns emerge continuously. And finally, it must be configurable, allowing customers to define custom rules, exclusions, and thresholds for their own applications. Here is the high-level system architecture. On the left, internet traffic arrives at the WAF edge, either directly or through a DNS layer and a CDN. The traffic first goes through a pre-filter that handles TLS termination, IP reputation, geofencing, and Layer 3 DDoS mitigation. Then a request inspection engine parses the HTTP request, normalizes it to defeat evasion techniques, and runs it through a rule engine. The rule engine consults a rule database containing OWASP rules, custom signatures, and managed rule sets. A bot detection service scores the request based on behavioral signals, JavaScript challenges, capture results, and device fingerprints. A rate limiter checks counters stored in a fast key value store. Decisions are logged to a high-volume log pipeline, and allowed requests are forwarded to the load balancer and origin application. Blocked requests return a deny response to the client. Security engineers use the management console to configure policies, inspect events, and tune rules. The key metrics to memorize cold. Blocked request rate, the percentage of total requests that are blocked, which helps detect active attacks. False positive rate, the fraction of blocked requests that were actually legitimate because false positives hurt business. Request latency introduced by the WAF, usually measured at the median and the tail, since latency is a top concern. OWASP Top 10 coverage, the percentage of critical attack categories the rules can detect. Bot score distribution, showing how many requests fall into human, good bot, suspicious, or bad bot categories. Rule hit rate per rule, which tells security engineers which rules are firing, and which may be obsolete or too noisy. And mean time to block, the time from an attack starting to the WAF effectively stopping it through dynamic rules or rate limiting. These metrics are what the business and security teams actually care about. Let's trace the end-to-end user journey. A security engineer at an e-commerce company notices unusual traffic on the login endpoint. She opens the WAF management console and sees a spike in blocked requests from a specific region. She drills into the bot detection dashboard and sees that most of the traffic is scored as malicious with suspicious headers and no JavaScript execution. She checks the rule hit report and confirms that credential stuffing rules are firing heavily. She creates a custom rate limiting policy that restricts login attempts per IP to 5 per minute and adds a managed challenge rule for suspicious requests. Within seconds, the WAF applies the policy globally, the attack volume drops, and the false positive dashboard shows no increase in legitimate user complaints. She then exports the incident logs for compliance and post-mortem analysis. The core models and algorithms. The request inspection model parses the HTTP request into headers, parameters, cookies, body, and path, then normalizes encoding and whitespace to prevent evasion. The rule engine evaluates signatures, regular expressions, and semantic patterns against the request, supporting actions like allow, block, challenge, log, or rate limit. The scoring model combines threat signals from signatures, IP reputation, behavioral anomalies, and bot classification into a risk score that can drive dynamic decisions. The rate limiter maintains counters per key using sliding windows or token buckets and supports both hard limits and adaptive throttling. The bot detection model uses heuristics, JavaScript challenges, device fingerprinting, and machine learning to classify clients. The log and audit pipeline stores request traces, decisions, and rule matches for forensics, compliance, and continuous improvement. The key trade-off is security versus usability. Aggressive rules catch more attacks but risk blocking real users. Now the low-level design deep dive. When a request arrives, a reverse proxy layer handles TLS termination and selects the correct virtual WAF configuration for the host. The request flows into a normalization pipeline that decodes URL encoding, handles Unicode, and canonicalizes paths so that attackers cannot hide payloads using encoding tricks. A rule evaluation engine runs the request through a sequence of rules, often using a state machine or tree-based matcher for efficient signature detection. Each rule returns a decision and a severity, and the engine computes the final action based on the highest severity or a composite score. The rate limiter checks a Redis-like in-memory store for counters keyed by IP, user, session, or API key. Bot detection may issue an asynchronous challenge or enrich the request with a score from a separate microservice. Allowed requests are proxied to the origin with minimal additional headers. Blocked requests are served a deny page. All decisions are emitted to a log aggregator using a structured format like JSON or Cap'n Proto. Rule updates are pushed to edge nodes through a configuration distribution service with versioning and rollback support. Key takeaways for your interview. First, a web application firewall is a Layer 7 reverse proxy with a rule engine, not just a network firewall, so emphasize HTTP inspection, normalization, and request lifecycle. Second, always distinguish between signature-based detection and behavioral or bot-based detection, and explain why you need both. Third, rate limiting is a first-class WAF feature and should be designed around the right key dimensions, like IP, user, session, or API key. Fourth, the hardest design challenge is balancing security and false positives, so mention tuning, canary rules, monitoring, and staged rollouts. Fifth, observability is essential because a WAF without logs is dangerous. Security teams must know what is blocked, why it is blocked, and whether legitimate users are impacted. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the Web Application Firewall. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the Web Application Firewall. We covered the full picture, from edge inspection and rule engines through bot detection, rate limiting, and the low-level design of the request lifecycle and decision pipeline. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.